Let's use the idea of nodes to identify the connection method of R1 to R2 to R3. So we're going to use the nodes. Okay, I'm going to highlight the first node here in blue, and then we have another one here that is magenta, and then I can identify another one here in almost a green color right there. So we have, this is node number 3, this is node number 2, and this is node number 1. Well, what's between number 1 and 2 is a resistor that is R1. And the current, according to the conversation we had, the current that is I1 here, that is passing R through R1, is going to go to R2 and 3. Now, the interesting part is that I2 and I3 are going to be the two branches of I1. I'm pretty sure you can see how I1 is going to go in these two directions. Like a river, well, rivers don't branch off, but you know, air ducts can branch off. So one of the ways to think about it is to take a branch off in a pipe. Now, I can simply say I1 equals to I2 plus I3. That's what I'm seeing in physical representation, and that's what I'm going to make a note of. Well, why is this important? Because resistors R1, 2, and 3, are they in parallel or are they in series? The three of them have no such relationship. But if I represent the circuit like such, and I say this is my R1, and I'm going to, instead of drawing R2 and 3 separately, I'm going to put them in one. I'm going to say this is R2 in parallel to R3. So basically, this here is the equivalent resistor of R2 and 3 in parallel. Now we can see clearly that R1 is in series with the equivalent resistor of R2 and 3. But I cannot say that R1 is in series with R2. That would be incorrect. I cannot also say R1 is in series with R3. That would be incorrect. In this side of in this representation of the diagram, we can say R2 and 3 are in parallel, but that's it. We cannot say anything else. Now, if we know that R2 and R3 in parallel, what we can do is, in reference to the lecture that we got, we can say that the R2 and 3, the equivalent resistor, is going to be equal to R2 multiplied by R3 divided by R2 plus R3. This is one way to calculate two resistors in parallel. But if you had more than two resistors in parallel, what you would do is you would say the equivalent of the resistors in parallel is going to be the sum of the inverse of every resistor there is. So in that way, you can either use this or you can use this to calculate the equivalent resistance. Now, this is the rules that we're going to apply to our understanding on how we analyze a circuit where there is both parallel and series connections of the resistors.